So it's coming up to that time of year again where we get to try and kill more plants. And in here it gets really hot because this is south facing. We always forget or never quite get round to watering the plants enough. So I'm going to make an automatic watering system that feeds each of the 3 shelves because they all get different amounts of sunlight and heat, and the windowsill over here, which normally has 2 big trays on with seedlings in. And we're going to try and make that all automatic so that we can leave it at least a week. So this is how we're going to keep the plants alive, hopefully. We're going to start with one of these little Arduino Nanos. And we're going to connect a load of these capacitive soil moisture sensors. Apparently you're supposed to choose these ones over the resistive style moisture sensors. The resistive ones tend to electrically corrode themselves. So these will control what happens to these. These are the relays that will turn the pumps on and off. And the pumps, because of the amount of current they draw, will have their own 5-volt supply and their own ground. And all of that is controlled with this little potentiometer. And it will give us a percentage number depending on where it's turned to. And that will dictate how much moisture content we want in the soil, which will be displayed on this little screen here. Let's get on to wiring this lot together. Okay, now we've made all that, we're going to just have a quick skim through the programming. It's all here and it will be in a link below to paste into your own system to your heart's content. You start with these libraries, you need these in. These basically make the LCD work, and then you have all the definitions for the LCD. I like the ones with the I2C system on them because it means they only use 2 analog pins to work. The soil sensors all have a maximum and minimum value, output value. And this defines them. This allows us to work out what percentage moisture level things are at for the calculation later on. And then we've got, in this section here, we've got the relay pins, just defining what they are. And below that is the potentiometer max min numbers that come out of that. So I had issues with the initial code that I made with the relays flickering on and off, and it was because the soil sensors were just giving a very noisy amount of data. And so what I've done to correct that minimize that is I'm taking an average over 30 readings. And so each one of these, there's 5 of these because I've got 5 sensors, and all the code is basically done 5 times. It's just a copy and paste. And I'm just changing the number on here on the end of each, with the exception of the number of readings, because that just reads off here. And you can change this if you want. If you want less noisy data, you can do it here. So now all that's defined, we can turn the thing on and turn on the serial port and make sure all the relays are turned off so it doesn't turn the pumps on unexpectedly. You then want to turn the LCD on, let that hang around for a while and then clear it. Then defining the potentiometer is an input. Then we go into the loop section, the analog pin for the potentiometer, and then putting it in through this map phrase that allows us to give that number a percentage. And then we turn that percentage into this phrase here, desired moisture, which will then appear on the LCD later. I'm not going to go through every one of these, but I'll go through the first one. So this is sensor 1, and this is taking the sum of all the readings and removing the oldest entry. Value 1 is equal to the analog, which is on pin A0. Take the reading index, and that equals value 1. That's the newest reading to the window. And then this adds the newest reading to the sum, and then this increments the index, gives you a percentage. It is then all averaged by taking the sum of everything and dividing it by the number of readings, and that kind of averages out over 30 readings. There's a whole load of serial port stuff just to kind of keep everything so we know what's going on. This bit of code takes the reading from A0 and prints it in the serial number. This allows you to configure the sensors so that you get that maximum min setting. And it then puts those into a scale, 0 to 100%, then that prints that all out so you can keep an eye on it in the serial port. And then this is the important bit, this is what turns the pump on and off. And that's saying that if this number here, this percentage number, is less than or equal to the desired moisture, then it needs to turn relay 1 on. And then importantly, if it's not that, and that the percentage moisture is greater than the desired moisture, it ensures that the relay pin is off. This is the most important bit. And then initially, before I did all the averaging stuff in here to reduce the noise of the sensors, this is the most important bit. And then it repeats 5 times. So you've got sensor 2, sensor 3, sensor 4, and sensor 5. So for the LCD, I wanted an average moisture of all of them. And it takes all the moisture percentages out of all sensors, and it just prints it to the serial port, and it also prints it onto the LCD. And then this little bit of code here is for the LCD, and it displays the average moisture of everything and the desired moisture. This may change by next week. I'm toying with the idea of having scrolling text of each one. I'm not sure how to do that yet, so if I do change it, I will update you next week. Anyway, there's the code. Hope that helps. So, we had a little problem with power. The initial plan was to power it off this with the Arduino pack thing, but it turns out when you plug it in, 5-volt pins don't give out 5 volts, even if it's off like the 9-volt battery that goes in here. These two are now dead. After that, and having to resolder the whole lot twice, I gave in. And got the connectors that allow you to change this out quickly, so that if I do blow this up again, I don't have to resolder everything again. But we now have the relays all wired in, and we have these all wired in, and we've got this wired in, and it all runs off USB. That's it. We're going to need a second power supply to run the pump because I can't use this. Well, hopefully that was helpful, and if you want to see how I turn it into a user-friendly product next week, please remember to subscribe, and we'll see you in the next one.